This is the most efficient way to find the area of a triangle. So let's meet our triangle. It's a right angle triangle. The bottom left hand corner is a right angle, so that's 90 degrees, or pi over 2 radians, or quarter tau if you're in the cool kids club. And it has sides of 1 3/4. So the first thing you're going to want to do to calculate the area of this triangle is draw a grid. This particular grid is 1 by 1, although other grids are available. Now we need to draw a line. This line goes as the hypotenuse of our triangle. Now, if we say that let the origin of this grid be the right angle, the bottom left-hand corner of this triangle, then we can find the equation of the line. The way to go about this is trivial and left to the viewer. So I've done it for you. This is y equals minus 4/3 x plus 1. The next thing you want to do, of course, is, well, you'd think I'm going to integrate it between, say, 0 and 3/4. But here we run into a problem, because I do want the most efficient way of calculating the area of this triangle, but I also need it to be accessible. So this integrating what is effectively y equals mx plus c is far beyond what I would expect someone to know. So I'm going to put it into simpler terms that the majority of people will be able to understand. Of course, I'm going to use polar coordinates, so we can substitute x equals r cos theta and y equals r sine theta, which I have done here. This makes the equation r sine theta equals minus 4/3 r cos theta plus 1. We can multiply that by 3 because I don't like fractions, really. What we can do now is add 4r cos theta to both sides, and then take out a factor of r, and then finally divide by 3 sine theta plus 4 cos theta to get our final equation, r equals 3 over 3 sine theta plus 4 cos theta. Now, I want this to be efficient, and we've got two trigonometric functions in here. That's hardly efficient. So what we need to do is use harmonic form. This is a neat technique that lets us turn a sine theta plus b cos theta into, well, usually it's represented with a capital R, but we're using polar coordinates, so we don't want to run the risk of mixing the two R's up. So I'm using n instead. So we're turning it into n cos of theta minus a. So we can draw a triangle here with the coefficients of the sine theta and the cos theta. So if we put the cos theta there and the sine theta there, so we've got a 3, 4, and the hypotenuse will be our n, and the top angle will be our a. So just through Pythagorean triples, we know that n is 5. Most triangles will not be this nice, and you'll probably end up with a square root. This is completely normal. You haven't done anything wrong. It's just that the numbers that have been used for this equation, for this triangle, happen to be such that it works out to be a 3, 4, 5 triangle. You'd swear I planned this in advance. So we can figure out a, that's just the arc cos of 4/5. So when we substitute that into our equation, we get r equals 3 over 5 cos of theta minus arc cos 4/5. Now already that's looking so much nicer than y equals minus 4/3 x plus 1. Now obviously I don't want to write arc cos of 4/5 all the time, because I'm lazy. Of course I'm lazy, because I'm trying to find the most efficient method to work out the area of this triangle. I would not be doing that if I wasn't lazy. So I'm going to just write a. We can treat it as an unknown even though we know what it is, because it doesn't affect our calculations. So what we can do now is integrate this. So because it's a right angle triangle, and the right angle is the angle at the origin, and as the grid showed, it was flat on the theta equals 0 line, so we can integrate this between 0 and half pi. or a quarter tau if you're feeling edgy. So as I'm sure we all know, the formula for integrating a polar graph, so our area is equal to this integral. So we can obviously substitute in r because we have the equation for r equals 3 over 5 cos theta minus a. And the next thing we do obviously is we square this fraction. Now this is why we turned our sine and cos into harmonic form, because now we don't have to worry about FOIL or anything like that. We can just square our one thing, which in this case is 9 over 25 cos squared of theta minus a. Obviously we can multiply that by a half, that's easy enough, multiplying by half, to get 9 over 50 cos squared theta minus a. Now, this is equivalent to 9 over 50 times 1 over cos squared theta minus a. And the beautiful thing is, in trigonometry, we have a separate term for that. We call that sec squared. So we can rearrange this to 9 over 50 sec squared of theta minus a. Now we can take the fraction out of the integral, because as much as I love fractions, we don't need them inside the integral. So we've just got a very simple integral, and as I'm sure anyone who's ever done trigonometric calculus will know, the integral of sec squared is tan. So now we have a equals 9/50 of tan of theta minus alpha from 0 to pi over 2, or a quarter tau if you're a rebel without a cause, or if you are a rebel and that cause is using tau instead of pi. So what you can do now is, well, just substitute a back in, because as I said, we already know what a is. So we can put that back in. So we're left with a equals 9/50 of tan of pi over 2, or a quarter tau if you don't like the rules, minus arc cos of 4/5 minus tan of minus arc cos 4/5. We can plug that into our calculator and we get that a equals 9/50 of 4/3 minus -3/4. Doing some basic arithmetic, we get a equals 9/50 times 25/12. Multiply those fractions together and you get the area of the triangle is equal to 3/8. Now, some people might say that we could have used half base height. But those people are wrong. Because I'm looking for the most efficient, the most easiest way to go about this. I'm looking for the easiest way, and like, this is not easy. Like, you have to figure out what you're going to use for B, you have to figure out what you're going to use for H, you have to keep checking back with the original triangle to make sure you're not accidentally using the same number twice. You'll make sure you're using the right numbers. I mean, you might accidentally put an angle in there, I don't know, something. And like, you got multiply by half. Like, why am I multiplying by half? What reason would I ever have to multiply? I'm just trying to find the area of this triangle. I don't want to have to multiply by a half, okay? So this is far beyond what I would expect anyone to know, and definitely way beyond the method that I would expect anyone to use. I think the method that I've shown here in this instructional video is clearly the most efficient way to find the area of a triangle.